Hello everyone and welcome to the next exciting episode of JavaScript, CIS 2033 scripting. In this episode I want to talk to you about things called variables. But before we go into variables, let's spend a little bit of time just talking about data. Computer data is basically defined as anything that's being true. A person's first name, their phone number, the price of a product, all of these things by themselves exist and are therefore true. So we would refer to any of those things as being pieces of data. Now, in JavaScript, data can come from a variety of different sources. On a web page, we may create a form. A user could then fill data into that form, and the data that was filled into that form would be available to us in JavaScript. Data could also be retrieved from a server, possibly through an AJAX statement, an AJAX call, which is something we'll talk about a bit later in the course. Data may be something that results from a calculation. For example, adding up the price of all of the different products that are in a user's shopping cart would create a total, which would be considered a piece of data. And a lot of data that we work with in JavaScript is actually created for us automatically by the web browser. Whenever the web browser renders a web page, a lot of different aspects of that page are going to be stored as different pieces of data that JavaScript will have access to. All of the different pieces of data that we work with in JavaScript are actually stored in the computer's memory. The computer's memory is something like a grid with lots of individual cells or places in it where different pieces of data can be stored. The data that's actually stored in memory can be a variety of different things. It can be collections of characters, what we would call in JavaScript strings. It can be numbers. It can be Boolean values like true and false. Just about anything you can think of can be stored in the computer's memory in each one of the different slots that are available. Each one of the different slots in the computer's memory has a unique address. The actual addresses that the computer uses to keep track of its memory are hexadecimal numbers. They're not very pleasant to look at or to work with, but we'll find here in a minute that JavaScript gives us a way around ever having to actually deal with those. Some different textbooks that I've read have often compared computer memory as to being something like stadium seating. If you think about seats in a baseball stadium, for example, each seat could potentially hold one person, just like each slot in the computer's memory could potentially hold one value or one piece of data. Each seat in the stadium also has a specific seat number, sort of an address that goes with it, like box 9, row 5, seat B, something along those lines. And just like that, of course, like I mentioned before, computer memory, each slot has a address so that that particular place can be talked about individually, uniquely. Data that we work with in our programs generally comes in two different forms. Some of the data that we work with in our program is data that changes while the program is actually executing. In the case of JavaScript, it would be while the page is actually being viewed. This type of data we tend to refer to as variable data, data that can change. We'll also, however, run into in our programs values that don't change while the program is actually running. These values are usually referred to as being literal values. Literal values in JavaScript could be anything that's enclosed inside double quotes, anything that's enclosed inside single quotes, any number that's put into our source code, this rough approximation of pi, for example, or certain keywords often result in literal data, like the words true, false, or null. All of the different literal values and variables are, of course, stored out in the computer's memory. Literals stored in different places, and of course, variables then are what we're primarily going to be interested in. Variables are going to give us a way of being able to store values in the computer's memory sort of at our own choosing, for our own convenience. And as we'll find out here in a minute, literals and variables, when looked at from this particular perspective, end up being virtually the same thing. Before we go on and talk a little bit more about variables specifically, a rough definition of a variable is simply that a variable is an abstraction for a memory address. This is what I mentioned to you before that will keep us away from having to deal with those hexadecimal addresses that the computer itself uses. More or less the way it works is that in our JavaScript programs, we're going to be able to define these things called variables. Here in this example, I have a variable that I've called first name. Variables can be given just about any name that you might realistically want, and every variable that we create refers to one specific area of the computer's memory where something can be stored, where a piece of data can be stored. So for example, in my JavaScript, if I were to say first name equals Bob, what would actually happen is that the literal Bob, inside quotes, would be stored inside the area of the computer's memory that the variable first name refers to. JavaScript does all this for us basically automatically. We simply ask for a variable to exist. JavaScript automatically substitutes in that variable name for a hexadecimal memory address, and then easily allows us to access whatever value happens to be, whatever memory address that particular variable happens to refer to. So if we were to do something like document.writeLine first name, for example, since first name is not inside quotes, JavaScript recognizes that it's not a literal and instead assumes that it must be a variable. Since it's a variable, it will find out that that variable represents one particular part of the computer's memory, will access the value that's stored there, and what will actually be output as a result of this statement then would be that value, Bob. Whenever we want to use a variable in JavaScript, we need to first declare that variable. Declaring a variable is basically us just telling the computer that we intend to use a variable of a particular name. To declare a variable in JavaScript, we use a special keyword called var, V-A-R. A keyword is simply a word that has a special meaning in a programming language. In this case, whenever we use the var keyword, it tells JavaScript that what we want to happen is to have a new variable created. So if I say var first name, as is shown here, what will happen is a first name variable will be created for me. Basically will be assigned to one area of the computer's memory so that I can store and then later retrieve values from that particular part of the memory. Whenever we create a variable, it's entirely up to us to decide what that variable's name is going to be, but there are some rules for naming of variables. For starters, every variable name must start with a letter. It cannot start with a number. A variable name should not contain what I'll call strange characters. You don't want to do things like put periods or asterisks, parentheses, braces, or brackets into your variable names. It's actually possible to make variables work if you do include those strange characters, but it becomes very, very inconvenient and isn't really worth the effort. So you should generally stick to the rule of making sure that every variable name you create starts with a letter, and then after that only contains letters, numbers, and underscores. The next rule is that variable names that we ask to have created cannot be keywords. Like I mentioned before, a keyword is a word that has a special meaning to the language. We'll run into quite a few of them here while we're talking about JavaScript. Var, for example, is one that we've already run into. If we were to use a keyword's name as a variable name, there wouldn't be any way for JavaScript to be able to determine whether we were referring to the variable or to the keyword. So there would be ambiguity, and JavaScript would result in an error. So stay away from keywords when you're making up your variable names. Besides that, variables can be of any length, so there's no reason they have to be short like in algebra. You don't have to name your variables things like X, Y, and Z. You can instead come up with longer, more meaningful names like first name. And that leads into the last rule then, and that's that variable names should be descriptive. You should generally try to make your variable names describe whatever particular value it is that they are going to represent, whatever values are going to be stored in the memory location that that variable refers to. It will make debugging and working with your code much, much easier in the long run, and it'll make the code that you write in JavaScript much more readable. All right, here I wanted to go ahead and just show you a couple of uses of literals and variables, actual uses of them here in some JavaScript code. What I have here, of course, is my standard transitional XHTML document. In the body, I've already filled in an H1 header for literals and for variables. And what I plan on doing is below each one of those headers, I'll use JavaScript to actually incorporate some literals and some variables into the body of my HTML document. So let me start off here below the literals section. by putting in a set of script tags. What I could then do here inside these script tags is something along the lines of a document.writeLine, where I could then, like I've done in previous episodes, just maybe, for example, print out what in JavaScript we would refer to as a string, like hello world, like we've done before. Here, hello world, inside double quotes would be considered a string literal. Literal meaning that it's not really variable, it simply is what it is, the way that it is coded here into the source code of the page. If I go ahead and save what I have here and switch over to my browser, hit refresh, you can see my headers show up, and hello world literal displays just there below the literal's header. There are certainly lots of other types of literals I could also display. For example, I could do something like document.writeLine, this is fun, inside a set of single quotes. In JavaScript, for the most part, double quotes and single quotes are interchangeable. If I go back to my browser and hit refresh, then you can see this is fun shows up. It of course also shows up on the same line, since HTML is not space sensitive in any way. If I wanted to maybe split those onto separate lines to make them a little bit easier to see, I could possibly put in an HTML break as part of the first string literal, so that when it is rendered in the browser, it would be as if I'd hit the enter key and everything shows up on separate lines. I'll most likely put those breaks in most all the rest of the examples that I do here. Next type of literal maybe I'll display is a numeric literal. Maybe I'll print out something like 1, 2, 3, 4. There we go. 1, 2, 3, 4 shows up. In the case of 1, 2, 3, 4, if I want to throw that break on the end, there of course isn't a set of quotes that I can put it in. So what I would actually need to do is use a plus sign to append two literals together. The 1, 2, 3, 4, the numeric literal, plus a string literal, the break. The plus sign here in this case is used to append those two things together. We won't actually be able to see anything show up from those at the moment because there's nothing yet below them. A few other literals maybe I could print out. What if I print out just the word true? You can see that comes up just as it is. If I do something like document.writeLine null, null comes up just as it is, and again I need to put a break in there if I want those to be on separate lines. There we go. Got it? Right. So lots of fun I can have with literals. Overall, they're really not terribly the most exciting thing, but they do come in handy every once in a while. There will be various different things that we can actually do with them. One other thing I might go ahead and try, just for example's sake, while we're in here, let me go ahead and put a break after the null that I have there. Okay. And then what would happen if I, for example, did something like document.writeLine and put in, let's say, a person's name, Han Solo. Right? Now you can see that what I've done here is I've purposely not put quotes around Han Solo. I just wanted to show you this so that you could kind of see how the browser is going to react. If I come over and take a look at my browser, it causes all kinds of chaos to occur. Basically, again, JavaScript panics, doesn't know what to do. The problem that we're running into here is that since I didn't put quotes around Han Solo, JavaScript is assuming that the word Han and the word Solo are both variables. Since I haven't actually declared variables with those names, JavaScript kind of panics and abandons the entire attempt. If I go back and I put Han Solo inside a set of quotes, then everything goes right back to working the way you would generally expect. That's not at all an uncommon problem, so I wanted to go ahead and show that to you just to make sure you would be prepared to look for that kind of situation when that kind of thing happened. That would also be another one of those cases where a single line comment could be very useful for debugging. If I went back and took those double quotes back off so that I'm left in a situation where, despite all of my JavaScript code, nothing seems to be working correctly, I could at that point go through and start commenting out lines one at a time using the double / to comment that line out so it will be ignored. I could go through each line individually that way, right? Looking for the one that, when it's commented out, leaves the script back in a working fashion again. Here I'll comment out the document.writeLine Han Solo without the quotes, and you can see at that point everything goes back to working. So that would identify to me that that particular line is the one causing the error. I could then focus on that one, hopefully figure out that the quotes are missing, and have everything go back to working the way I'd like it to. Now that I have some literals in there just to play with a little bit, let's go ahead and take a look at some variables. I'm going to come down below my variables header at this point. I'm going to insert a set of script tags. In this set of script tags, what I want to do is basically print out the same values that I had in there before, but what I'm going to do this time is instead of printing them out strictly as literals, just straight literals the way that they were before, I'm going to actually create variables and store each of those separate values in a variable so that we can then print out the actual value of the variable. So what I'm going to need to do here is I'm going to need to create a variable, declare a variable. I'll go ahead and create a variable here called sentence, let's say, for example. Okay? When I create that variable, I do it by typing var space sentence. That simply tells JavaScript that I want a new variable created for me and that I will refer to that variable as sentence. Once that's done, I can then assign to that sentence variable, using the equal sign, whatever it is that I'd like. I could, for example, put hello world there. Once I've actually put a value into the variable, I could then do something along the lines of tell it to print out sentence. Now, unlike our Han Solo problem before, now when I use the word sentence without quotes around it, JavaScript will find a variable by that name, and what it will actually do then is it will access the value that is stored in that variable, and it is that value that will actually get printed out. If I bump back over to my web browser and hit refresh, you can see there's the hello world that shows up. That last hello world after the variables header is actually the value of the sentence variable that's being printed out for me. Now, since sentence is a variable, I can actually change its value at any time. I could do something like, say, sentence equals this is fun. Right? So that then, when I actually print out the value of sentence, what will come out is this is fun. You'll notice that hello world and this is fun did not both print. The particular type of variable that we're dealing with here is referred to as a scalar variable, which basically means that it can only hold one value at a time. When the sentence variable is first declared, it has no value at all. Well, it actually does have something of a value in it, a special value in JavaScript that's called undefined. When I then go and put the hello world value into it, hello world gets stored in memory in the location that's specified by the sentence variable. When I then come back and say sentence equals this is fun, the this is fun value actually replaces the hello world value that was in sentence previously. So at this moment, when I then go and print out the sentence variable, all we see is this is fun. Hello world has been basically demolished in favor of the new value that was assigned to that variable. Okay? Another neat little trick that I can do with variables is that when I declare them, maybe here I'll create a variable, for example, called number, I can actually go ahead and provide an initial value to that variable at the same time I'm declaring it. So I could, for example, say var number equals 1, 2, 3, 4. If I then come down, I'm going to add a break after my sentence variable, and then I'm going to do a document.writeLine for number so that I can see my number variable's value displayed. Okay? You can see that works just fine. So in the case of sentence up here, all we were doing was declaring the variable. But here in the case of number, we were both declaring and initializing the variable, all in a single statement, which is a nice little shortcut and is probably the way you'll do it a pretty good amount of the time. We could go ahead and do basically the same thing with true, with null, with Han Solo if we chose to, but it would really just be more of the same. So just to show you one other thing real quick, let me make one more variable. I'm going to call it nothing. Right? I'm not going to initialize it. Instead, what I'm going to do is I'm just going to come down, do a document.writeLine for it. I'm going to go back and add a break in after the number so that we can see everything expressed on its own line. When I then come back and actually look at the output that was created by trying to display the value of a variable that I never assigned a value to, you can see what we get is undefined. Undefined is sort of a magic value inside JavaScript. It's something that's always kept in place of an actual value until an actual value is present.
What I'd like to do next is I'd like to show you a new JavaScript statement called the prompt statement. The prompt statement is sort of a close relative of the alert statement. What the prompt statement will actually do is it will pop up a dialog box, very much like the alert does, except the prompt statement will also then allow the user to actually enter some input, which the prompt statement will return to us as a piece of data, which we can then actually store in a variable. So let's go ahead and give this a try. I'm going to start by putting in a set of script tags. The actual prompt statement itself is just the word prompt followed by a set of parentheses, formatted very much like the alert was. Inside the parentheses, after the word prompt, I can put in a string literal. And what this string literal will become is the actual message that's displayed on the prompt that pops up. So I could put in here something like enter the radius of a circle. Let me go ahead and finish that statement off with a semicolon, and let's just go ahead and take a look at how it works as it is right now. If I go back over to my browser and hit refresh, as soon as the browser executes its way down to the prompt statement, when the prompt statement is executed, this is the way it comes up. You can see the string literal that I entered, enter the radius of a circle, comes up as sort of the prompt, I guess would be the best way to put it. And then the user then has the ability to type in some value, so I could put in 20, for example. I'll then go ahead and hit OK. At that point, this particular script is actually done, but there was something else that actually happened in there that we didn't take advantage of. Oops. And that is that the value that was entered into the prompt was then returned whenever we hit the OK button. So if I were to create a new variable here, maybe call it radius, for example, and I were to assign to the radius variable the value that is returned from the prompt, we would end up with that radius that the user entered stored in a variable where we could then make use of it later. So just to show you that we actually have it, I'm gonna put in an alert where I'm going to print out radius entered is, and then I'll append to that just the word radius, which, as we discussed previously, means that we'll be accessing the actual value that's stored in that variable. So if I go back to my browser and refresh, it asks me to enter the radius of a circle. I could then type in my radius and click the OK button. You can see that the value that was entered by the user was indeed stored in my variable. So in my next statement, the alert, it took that value, appended it to the rest of the string, and we ended up with an alert that says the radius entered is 20. We could go ahead and then take this example one step further. What we could do here is we could actually calculate the area of the circle that had that radius, just pushing what we've talked about in JavaScript a little bit further than we've gone before. What I'm going to do here is I'm going to declare another new variable. This one I'm going to call area. And to actually get the area, what I'm going to do is I'm going to take the value of pi, or a rough approximation of it anyway, 3.14159, and I'm going to multiply it by the radius times the radius. So pi r squared basically is what I'm doing here. I could then go ahead and display that value with a little bit of formatting to make it look kind of nice. I'll say the area of a circle with a radius of, and then I'll append in the value of the radius variable. And then let's see, we'll say is, and then we will append in the value of the area. At this point, this alert statement is really not needed, so maybe for right now I'll go ahead and just comment it out. If I switch back over to my browser now and hit refresh, it asks for the area of the circle. I'll put in 20. It tells me the area of a circle with a radius of 20 is 1,256.636, which I'm sure is absolutely right. Maybe I'll have to get out my calculator to be sure. Let's try another value. I'm going to hit refresh. When I hit refresh, it of course reloads the page, re-executes the JavaScript. I'm going to tell it that I have a circle with a radius of 1, in which case it comes back and tells me the area is 3.14159. So it does look like that calculation is being performed correctly. So there we go, the prompt statement, storing values into variables, both through the prompt statement and through a calculation we did ourselves, and then being able to access those values in those variables.